IT departments are facing an escalating problem. Organizations desperately need to modernize their legacy systems, but traditional development cycles are too slow, rigid, and expensive to keep up with the demand. This creates massive operational friction. Microsoft Power Apps is often positioned as the immediate fix for this gridlock, but there is a major trap waiting for teams who adopt it. They treat the platform as a single, simple drag-and-drop tool. This infographic shows the shift away from traditional development. Instead of expensive, isolated systems that take months to plan, Power Apps offers a lower-cost, integrated environment that connects directly to your existing data sources. To use it effectively, we need to look past the marketing. The reality is that Power Apps is a robust, multi-tiered ecosystem consisting of 4 entirely distinct development architectures. This panel details those options: Canvas, model-driven, code, and vibe coding. Each of these tools requires different levels of technical expertise and offers completely different scalability limits. Here is the structural dilemma. If a team selects Canvas when their data actually demands model-driven, or they try to use Vibe when they really need Code Extensibility, the project will eventually hit a developmental wall that requires a total rewrite. We are going to dissect these 4 tiers. We will compare their core trade-offs, identify their limitations, and determine exactly which one you should deploy based on your specific data requirements. The architectural foundation you choose now determines the technical ceiling of the application before a single line of logic is written. Let's start with the most accessible tier, Vibe Coding Apps. This serves as the AI-driven starting line for modern application development. Looking at this interface, you see the primary input method. Users type natural language prompts into the "What do you want to build" box. Based on those descriptions, the system instantly generates functional baseline MVPs, complete with necessary back-end data structures. The trade-off is precision. Because you are relying on an AI interpreter, you need strong prompt engineering skills to get the exact result you want. Furthermore, any generated logic requires strict manual auditing before you can safely deploy it in an enterprise environment. For builders who need absolute visual control, the next step up is the Canvas app tier. This is a strictly UI-first approach. This dashboard shows Canvas in practice. You drag and drop visual elements, like labels and buttons, using manual PowerFX formulas. The result is complete design freedom, tying custom screens into hundreds of data sources, like SQL and SharePoint. But that blank slate comes with a heavy administrative cost. Because nothing is structured by default, security protocols, user roles, and responsive layouts must be manually configured. Additionally, performance can take a massive hit. If a single Canvas app pings too many disparate data sources simultaneously, load times spike and the user experience degrades. Vibe and Canvas excel at rapid deployment and bespoke interfaces. However, they leave the heavy lifting of data architecture and compliance entirely up to the creator. To solve those architectural and security challenges, we flip the equation. Model-driven apps act as the exact inverse, taking a data-first, purely structural approach. This infographic outlines the strict input requirements.
First, developers define relational data structures, business rules, and security rules within Microsoft Dataverse. Once set, the system automatically generates functional, enterprise-grade user interfaces based on those data tables, like the forms shown here. The major benefit of this process is stability. You get out-of-the-box role-based security inherited directly from the database, allowing the application to scale across tens of thousands of records. The critical trade-off is flexibility. The user interface is highly rigid. You are locked into Microsoft's specific component design language, and the application is strictly tethered to the Dataverse ecosystem. When low-code solutions hit their structural or visual limitations, there is a final tier, Code Apps. This serves as the professional developer escape hatch. As you can see in this environment, we leave visual builders behind entirely. The input here requires professional developers writing React and TypeScript, leveraging the Power Apps component framework. This grants infinite extensibility. Engineering teams can build deeply custom components, deploy advanced DevOps pipelines, and handle the most data-intensive edge cases an enterprise can generate. Deploying Code Apps sacrifices the primary cost-saving benefits of citizen development. It requires expensive, specialized engineering talent to build and maintain the infrastructure. Canvas prioritizes how the user feels when they interact with the screen. Model-driven and code tiers prioritize the integrity, security, and scale of the enterprise's data underneath it. We understand the technical inputs and limitations of these 4 tiers. Now, we have to map the right architectural tool to the specific business problem you are trying to solve. This matrix compares the core philosophies of the 2 dominant platforms side by side. On the left, Canvas is completely UI-driven. On the right, model-driven is entirely data-first. The mandate for Canvas is clear. Choose Canvas apps when the end-user experience is the highest priority, the application is a lightweight task-based tool, or you need to aggregate data from multiple external sources onto a single screen. Alternatively, choose model-driven apps when you are dealing with complex relational data, strict security governance is required, and heavy back-office CRM operations matter more than a custom look. You should only branch into code apps when custom integrations or highly complex bespoke business logic exceed the technical capabilities of those default visual editors. Complex enterprise requirements often lead to a hybrid deployment that utilizes the specific strengths of both primary systems simultaneously. To structure this hybrid approach, you build the backend, security permissions, and business logic within Dataverse using model-driven architecture to enforce relational data constraints. Then, to achieve a specific user experience without sacrificing backend security, you overlay a Canvas app strictly as the front-end interface. The final trade-off for this hybrid architecture is talent. Executing it correctly requires a development team with deep expertise in both UI design and relational database management. Power Apps provides an elastic platform that scales with organizational requirements, provided the deployment respects architectural boundaries and starts with a sound data strategy.